Hello. Now I am here with the exam style questions of your unit 4, and later on I will be discussing about the past paper questions for you. Hope that it will make clear sense of understanding of the topic what I have uploaded to you for in these previous 4 videos. Here we go. uh, in this question number 1, this is asked the correct unit of the electric field strength is. So here there are several units for you. Electric field strength is E, and if I see that the equation which helps you out, that is equals to E equals to F divided by Q, or it was delta V divided by D. So in this all, basically the situation is in front of you, that if I say that the unit is Newton per coulomb, okay, or you can say volt per meter. So which unit is here? So there are two traps in this question, which are usually the traps for the student: this one and this one. Here it is written Newton coulomb. Basically your answer should be Newton per coulomb. Okay, Newton per coulomb or Newton coulomb minus 1, and the second answer should be volt per meter, yani volt meter minus 1, not volt into meter. That is why if you see, option B is the right option for you, because here it is written kilovolts per meter. So yeah, that can be kilovolts per meter, can be the right option. Now, question number 2: which of these particles is not affected by electric field? Not affected by electric field. So, definitely all the particles which have charge, they are affected by electric field, but those particles which do not have charge, they are not affected by electric field. So, electrons, yeah, they are affected. Neutrons, yes, these are neutrons are the particles which are not affected. So, it would be its option will be option B. This was quite easy question. So here we go. Next slide. On that slide, end of the chapter exam style questions. An electric field strength between from a negative point charge. Yes, there are 4 options for this one. The electric field strength from a negative point charge is, here I will draw the diagram and then I will explain to you. Negative point charge mean there is a charge which is negative and it has a field lines. Yes, as I mentioned, that the field lines are always from positive to negative. It means this will have all the field lines into towards its center. So that is actually, it is said that it has radial lines, which is actually described in detail in your next topic, but here I'm gonna draw the diagram for you for your convenience. So these field lines are radial. So now let's see which is the right option. Yes, decreases in magnitude with a square of the charge. Okay, we can consider it, because this is actually, the question is asking that E is inversely proportional to square of R. Yes, we can consider it. This is the right. This is one of the options. Then decreases in magnitude with the square of the distance from the charge. Second, increases the magnitude with the distance from the charge, and increase the magnitude with the square of distance from the charge. So here I will explain you this in detail, that electric field strength is actually the force per unit charge, that is force per unit charge, and electric force, which is actually the part of the point charge forces, that is 1 upon 4 pi epsilon naught q1 q2 divided by r square, and this q will be cut by one of the q's. So that is why your entire discussion is now that as you move away from this charge, this is a, let's say, a negative point charge, So as you move away from this point charge, what will happen? The electric field strength will decrease by inverse square law. That is the right option. So that is why it decreases by its magnitude decreases by inverse square law as the distance from the charge increases. So right option is option B. Then a force between two protons held at 1 Newton meter apart is equal to this. So we will calculate the force by the same formula which I have mentioned here in front of you. So let me calculate that, because for the protons the charge is given to you, so force is equals to this 1 upon 4 by epsilon, that is equals to 9.0 into 10 raised power 9 into charge of one proton is 1.6 into 10 raised power minus 19, so that this is the other charge is also having the same charge, other proton, sorry, and that is separated by 1 nanometer. 1 nano is 10 power 9 minus 9 whole square. So that will be by multiplying this 1.6 square times, let me show you my calculator, 1.6 square, all these values I will try to place all these values in the calculator, and then I will show you the answer. Here is my calculator. The value was it's 9.0 exponent 9 times, yes, this is the value, sorry, yeah, here we go, times, yeah, let's put the bracket because it is 1.6 exponent negative 19 square. I have to put square on this, and it's all is divided by, yes, what was that value? Yeah, the value was 1 nanometer, 1.0 exponent minus 9 square. So you got 2.3 exponent minus 19. So this is your right option. So here we go again. This was the point what I was calculating. So 2.3 into 10 raised power minus 19. So this is your electric field. Okay. Electric force. So here we go in the next slide. Which row in the table correctly shows the properties of both uniform and radial electric field? So uniform electric field is from positive to negative, and radial electric field is basically the lines that has the equipotential equally spaced, and field lines equally spaced, and equipotential equally spaced, and field lines from positive to negative. So here that is basically for uniform field. The reason the uniform field, the identification is that the field lines should be equally spaced, right? When the field will be uniform, then the lines would be equally spaced, and radial lines would be equally spaced at equipotential surface. Okay, so this would be the right option will be option C. This is now the theory parts. So I will write about this, explain what is mean by the uniform electric field. So there are 2 points for this. Uniform electric field lines are uniform electric field is that field which has the field strength same at all the points, and it is represented by the parallel field lines, and these parallel field lines are equispaced. Second part, describe how uniform electric field can be demonstrated at laboratory. 3 points. So for laboratory experiment, you can say that we can have 2 plates or 2 wires. They can be connected with a voltmeter, or you can say with the help of a variable power source. Okay, and you can adjust the distance between these 2 plates, and by that you can consider that, yeah, one plate will be considered as positive, the other plate will be considered as negative. Let's say this is the positive plate, this is the negative plate, because this all will be done by you, and that means it would be settled down. And now you will place any charged particle, like any sort of oil drop or any sort of spray particle, then it would be deflected from positive plate towards the negative plate. So that shows that yes, the electric field lines are from positive to negative plate. So this is how we can demonstrate it. I have not written a lot of details, but I believe that you got it. So next questions I will explain in my next video, because they need some calculations. It will take time, so I'm gonna upload the video in my I'm going to solve these questions in my next video.